понимаешь, что 3 квартиры сожрали? Нет, есть как бы, ну ладно. Так же, как наоборот. Претензии ко мне. Ну я шучу, да. Наоборот. Никого не обижаю, просто да. Не знаю, в чем-то, блин. Потому что ты играешь, говорит, плохо. На себя играют только. Molly. Oh, by the way, it was. Wait a second.
For the model to understand how to use the API.
Exactly. But before we send the message, what actual message should we send to people?
I mean, there should obviously a hello world, as well as something truly useful, like the price of Bitcoin.
That sounds extremely useful. So we'll ask the model to look up the current Bitcoin price.
Let's see if it works.
All right, so it seems to have done something. And by the way, this particular API, I guess, is used enough out there in public code that the model felt it was worth its while to memorize exactly how it works. And now let's actually send an email blast. Now send everyone an email telling them A, hello world, and B, the current Bitcoin price. So we'll leave it a little bit up to the model to decide exactly how it wants to format that email.
Yeah, I'm curious what messages we'll choose.
Let's see what happens. All right.
Oh, looks like a very sensible message.
Indeed. So now it's calling the MailChimp API. So let's give it a moment. Spinner is still spinning.
Yeah. So it will probably, oh,
there we go.
That's a lot of emails.
Yeah, so we're sending 1,472 emails. It may take a little bit of time for these to deliver. Again, at this point, Codex has done its job. At this point, we made the call to MailChimp. MailChimp is queuing these emails up on its servers as we speak. But as you receive the emails, please post in Twitch chat so everyone knows that they were received.
So I feel like it was a pretty satisfactory Hello World demo.
I think this is the world's most advanced Hello World demo.
And while 1,472 lucky recipients are waiting for the email, it's time for us to move to our next stage.
I think so.
Let us build a game.
All right, so we've shown building, sort of very simple functionality, right? So that it's kind of single shot, it requires a little bit of back referencing, but mostly it's you ask for a particular thing you want done right away, and maybe it involves doing some complicated import of a particular API and use it in a specific way. But what we want to show now is building up a more complex program, actually, sort of building something that spans many lines of code.
That's right. And the game I have in mind is one where a person will be trying to dodge a boulder.
All right, well, let's give that a try. So first of all, I'm going to look up a silhouette of a person. I figure we should probably not use a real image of a person for this because they're going to get squashed by a boulder.
It is a very wise choice. And what you see here is something very similar to the previous demo, where Greg is typing the instruction to the text box, then he presses play. The model does its neural magic and produces code, and now we get this oversized person on the page.
Yep. And I want to point out, so the only difference here, as far as the output is concerned, is this is outputting JavaScript as opposed to Python. It's actually the same model under the hood. So the only piece of magic we're not showing you right now is we provide a little bit of context to the model. In the case of Python, we have just one example of following an instruction in Python. In the case of JavaScript, we have like 2 examples of doing it. And from there, the model latches on and just continues and continues.
Yeah, so I feel like it was a good first step, but what I would really like is for the person to be a lot smaller and for it to be controllable with the left and right arrow keys.
Great. And we also just got a report that the emails have started rolling in, so I think that's a success for MailChimp and for Codex, so I think that's great. So let's see how big we want to make the person, maybe 100 pixels. Does that seem about right?
Let's find out.
All right, let's give that a try. And actually what I'm going to also do is I just want to show people the full prompt that's being sent so that you can really see what's going on without any magic. So I just opened up the Chrome Inspector, we have the completions endpoint, and you can actually just scroll to the post message, and you can look at the entire bit of the prompt. And let me show you what that looks like, expanded out.
And to just explain what you're seeing here, the way this neural network works is that it's a really, really good pattern completion system that happens to work on patterns in code. It's like the world's best yes and improv actor whose domain happens to be code rather than improv.
Exactly. And so we simply provide it with this context of, oh, you're supposed to follow some instructions. And then the model realizes my job is to latch onto instructions. Okay, so let's get back to building. So we've got the person with 100 pixels, a little pretty good.
I think so.
All right, now what do you want me to happen next? What do you want to happen next?
So I want it to be at a reasonable position at the bottom of the space of the screen and to be controllable with arrows.
All right, well, let's do that. So first, let's set its position to, let's say, 500 pixels down and 400 pixels from the left.
Seems reasonable as far as I can tell.
All right, let's see what happens. All right, perfect. And now make it controllable with the left and right arrow keys. Now this is a pretty high level instruction. You know exactly what's supposed to happen when you push left and what's supposed to happen when you push right. You know, the model really has to infer what's going on in here, and it can't look at the screen. The model only has access to all of this text over here. And so from that alone, it has to infer what to do. Well, let's see if it worked.
Let's see, I'm curious myself. The code looks reasonable. Okay. It's quite good, but this looks like something I don't quite like. I don't want it to be able to get out of the screen like
All right,
this.
you found the problem.
Yes.
But it is alive, which I think is pretty good. But let's see if we can fix that problem. So constantly check if the person is off screen and put it back on the screen if so. So again, pretty high level. It's possible that the model won't quite know what we're asking for, but let's give it a try.
Okay,
Go
let's
ahead.
test it. Okay, this side looks pretty good to me.
It's pretty good.
What about the other side? Let's see what's happening there. Okay, so that looks good too, except that you see this flickering scroll bar at the bottom.
That is no good. Well, fortunately, you can just say disable scroll bars. By the way, I actually don't know how to do this in JavaScript.
Does the model know?
Well,
Let's
find out.
test. The model does know.
There we go. So phase one complete. The person is movable.
So there is a suggestion from Twitch to see if we can make it move upwards if you press spacebar.
All right. Well, let's give it a try. So also make the person move upwards if you press spacebar. Give that a try. All right. You think it's gonna work?
Let's find out. Oh,
And there we go.
that is nice. We need to make it also move downwards.
Oh no. Okay. And
So make it move downwards if you press the down arrow key.
so we now have this nice
А
flying
гравити,
person.
когда ему гравитацию сделай.
Let's see.
Gravity.
Okay, so now we have given it full,
Okay.
all directional
Good,
control.
good. All right, perfect. So we now have this very nice game where the person can go anywhere with very unintuitive usage of spacebar.
That's
but,
right.
you know, if you want to modify this, please feel free to try it at home. One of the great things about this playground is that it's very easy to export these commands. You know, you can almost think of this text as the new kind of source code, and people can modify it and fork it. So I think we're going to see lots and lots of games appear once people start playing with Codex.
Okay, so a moving person is quite nice, but we need to get a boulder that we'll be dodging.
All right, so let's search for an image
Нет,
of
ну
the
нет.
folder.
This one, definitely.
This folder. All right, it's a very nice folder.
I could not agree more.
I would not want to be that person having to run away from this.
Okay, so once again we
Yes,
just
maybe.
request for the boulder to appear, and it appears. I hope it will appear.
Oh, it does appear.
An oversized boulder.
Massive boulder.
Let's make it smaller.
All right. How many pixels?
Can you just ask it to be small?
Oh, that's a great point. Make it small.
Okay, this is too small. Can you ask it to be 4 times as large?
Let's give it a try. That's actually interesting. So it actually used a style.transform. Transform. Now you might want to do it that way. If you want to do it a different way, you can also just say, set the width to be 4x larger. And the great thing about JavaScript, all this JavaScript just running directly in your browser. And so we actually have all of this playground set up so that if you don't like an instruction, you can just delete it. If you want to modify it, you can always just edit it, and then you can edit the code directly.
Yeah. So I like the size of this boulder.
Perfect.
But now I want it to fall down.
Okay.
And then when it hits the ground, I want it to reappear from the top again,
Okay.
somewhere else.
Now, the thing about codecs is that, again, coding is two things. It's deeply understanding a problem, figuring out how to chunk it up into smaller pieces, and it is secondly mapping a small chunk of problem statement to code. And codecs really excels at that first part. The first part, if you ask for too much at once, it won't succeed. And so let's actually give it a try, just to say, now fall from the sky and wrap around.
Okay. I wonder if it will work. Let's find
Yeah,
out.
so this is going to require doing a lot of things. So in fact, if you notice, all that it did is it just did the first part of saying, I got to get it absolutely positioned. I put it in a particular location. It didn't do the second part. And so when codecs fails like this, the kind of thing you can do is you can just try again. And I think that, again, like one really nice thing about doing this in JavaScript is there's no punishment for getting it wrong. Right? You have a system that's very stateless that you can just re-execute and try again. Your iteration cycle can be just truly immense. And that for me has been kind of the most exciting part about working with codecs, is that it just kind of means that you get to just think about what you want, and you spend less time of like, okay, now I need to go to Stack Overflow and figure out how, whatever property it is to disable the scroll bars, which I have already forgotten. But let's now try breaking down this instruction into smaller pieces. So first, I think codecs had a good point that we should set first position it let's set its position to the top of the screen at a random horizontal location.
Hopefully that's a simpler instruction that it could do.
Seems pretty good.
And it did it.
Yep, and if we want to verify it's actually random, we can just kind of re-execute this code multiple times. It seems pretty random to me. Now have it fall from the sky and wrap around.
Okay.
Let's try. So again, still a lot going on in this instruction, so it may not work.
The
But
code
let's give
is
it a
sense.
try.
Oh, it's moving. It's going down.
Moving. Okay, we got something. We got some signs of life. Got some signs of life.
Is it going back?
And
Yes.
there we go.
All right.
Very nice.
This is very nice indeed.
It is alive. All right, great. So I think in order to put a capstone on this game, we just need to.
Indeed, there's no game if you can't lose.
Sad to say, but we do need to implement that loss condition. So first, define what happens when you lose. Clear the screen and show a message saying you got squashed.
It should be an encouraging message, ideally.
Okay, well let's. So I just kicked this one off. Let's make it encouraging. So now modify that function. Now rewrite that function to also include some words of encouragement.
Excellent. I'm also curious what words of encouragement the model would choose.
So you can do it. So that's pretty good. And so the only thing is that the way that this actually was implemented is implemented as a key down listener. And what we really want is we want a function that gets called when you lose. So we can get rid of both of these. We can try this one more time.
And so how would you make it different?
So you can
Вот это
say,
есть там самый, да.
define a function
Да,
So
вот это и
make
было на самом деле,
function
свет, что ли, наоборот.
that gets called.
Ага, ну нет,
Okay, let's see if it works. Oh, it is a function.
It is called you lose. And now rewrite that function to include words of encouragement. All right, let's see what happens here. And sure enough, it makes a new
Try
function.
again.
All right, let's see what happens. Now we actually have to wire this function up. So when the person and the boulder overlap at all, so constantly check. If the person and the boulder overlap at all, and if so, you lose. So I'm not even going to say explicitly call that function. Just, it's got to figure out that that's what we want. So we'll see if that happened. Ilya, do you want to do the honors?
Definitely.
Oh man. All right, moment of truth here. Moment of truth.
Success.
You got squashed, and a very encouraging message to try again. I think that's very good life advice from Codex right there.
да.
Okay. I feel like it was a nice game that we built in a small number of minutes.
I think so. So we have one more thing to show you. And that with this demo, we want to help expand your mind to the possibilities that Codex can really offer.
And indeed, one of the things that we showed you in the Hello World demo is that it's very easy to teach the codex model.
Ты наоборот, наоборот, просто Так нет уж, наверное, да, это. Эх, мало.